Dubbing with S2SS, Let Your Subtitles Speech. This video was also created using ElevenLabs S2SS and has been translated from the original Turkish into English.
Hello everyone, with this video I would like to tell you about the current 2.0 version of our free gTTS S2SS application, which is the first of our applications that we told you about the 1.0 versions last year. In this video we are going to do an experiment on how to dub quickly. Now I found a video like this from a speech of Zuckerberg. I took a section of about 40 seconds from his 22-minute speech as follows.
The future depends on all of us. Great to be here at Georgia. He was a powerful and for bringing people together.
To dub this conversation, we assume that we have subtitles in this free version of the app, but before we assume, let's try to get subtitles anyway. For this, I would like to show you the subtitle files that we will need in all these steps from the new version of our ElevenLabs application, which we plan to share with you soon, and how we will obtain their translation. For example, here we will immediately use the famous program we have prepared for subtitles, and Whisper AI, or you will be able to use ElevenLabs' new transcription method called Scribe, which you can also access through this program interface, or another subtitling program called Assembly AI to get your subtitles. You will be able to use these programs for free with ElevenLabs, Google Cloud, and Microsoft Azure. Now I want to use the OpenAI Whisper section here. For this I will enter my OpenAI key. Here I enter my OpenAI key quickly, and here as input media, I select this video of Mark Zuckerberg, which I call a 40-second Z sample, and it asks me to select an output folder before continuing. I said FO1 here. Since I have selected something that is not MP3 here, the program wants me to run this button first. I am running this. Now our Generate Subtitle button is active. Now we will try to get our subtitle by pressing this Generate Subtitle button. From the options here we can get many subtitle types in the subtitle called Sentences Classical. Here is a section called First Speech Time. Sometimes some of your videos may not start speaking immediately, and sometimes OpenAI server can start it from 00 even if the speech starts later. Therefore, if you know how many seconds the first speech is, this is just a method we use to determine the duration of the first subtitle, but since OpenAI fixed this in the last trials, they started to give the time when the speech starts again in Sentences Classical subtitle. They fixed this in the last month. Now let's try Generate Subtitle. Here it tells me how much the OpenAI server will cost me, which is $0.06 per minute. Here it costs $0.006 for 40 seconds. So even if it exceeds 1 second, it will cost us $0.006, which is a very reasonable price because it considers it as 1 minute. Now let's run it and get our subtitles from OpenAI servers very quickly. I've started it. In a few seconds, look, we got the results quickly. Now let's see our results. We said FO1. Here we have different types of subtitles that we take as classic subtitles, and we can use one of these two results for our sentence-by-sentence subtitles, which is our more suitable format. One is this and one is this way. The longer one is for longer speech, the shorter one is a bit more sentence by sentence, but it is the part that we create by dividing it from the first sentence we see, which achieves more accurate seconds, but there is a risk of speeding up. The advantage of the longer sentence is here because we can take as much time as possible, therefore it reduces the risk of acceleration. The block length and time length going to the API in one go increases the probability of being sufficient. Now let's use shorter for this here. Let's try to see if it speaks accurately at different times. We will use this, but what was our goal? Of course, since it is dubbing, we need to translate it into a different language. To translate it into this different language, we will try to translate it using the DeepL API from the interface of our ElevenLabs application. Here I am entering our DeepL API. Here I want fetch language, and the languages are pulled from the API. The advantage here is that it gives us a very generous character count of about 500,000 characters per month DeepL. So this will help us translate video subtitles and characters for at least 6 hours or more. Now what was our goal here? Well, we're going to take the subtitles from our previous subtitles in the FO1 folder. I choose the subtitle that is not what we call longer, but shorter. sentence sentence, which is a short sentence sentence sentence. Let's call our output folder the DZO1 result in free gTTS. So let's accept where the result translated with DeepL comes from and select it. Now, if I know that the input I give is sentence by sentence in the subtitle file, I check the checkbox so that it translates block by block. Let's get a result closer to the result we want. In case you give a classic subtitle, even if you don't check this, we are trying to give a sentence by sentence result in which both the classic translation and the timestamps are preserved or weighted. Let me say that in advance. We will explain it in more detail in the future, both in ElevenLabs and in the videos we explain specifically for this program. Now I have selected sentence by sentence translation, direct language OTA, the language we will translate. For example, let's translate it into German. Here I chose German and we chose where we wanted to translate this subtitle as D01, and let's say translate. Look, our block by block translation has taken place. Now let's look at our translated subtitle in our DZO1 folder from here. See, here we can get the results translated into German here. Now, in order to reduce the possibility of acceleration here, because some blocks can be accelerated to fit exactly the relevant times. In this program, logically, we have to do this to maintain synchrony. But we have taken many measures to preserve synchrony as much as possible. Among these, we have an optimized long subtitle block application that we have not yet mentioned. I will talk about it soon when I explain it in our other programs. Here we will make shorter versions of subtitles, but with the meaning intact. After preparing our subtitle, when we click on the language selection section here, the language options come up nicely. Here I choose German. As input SRT, we give our German subtitle that we have just prepared as input in this way. Then we give our input video. In the previous 1.0 versions, we had to change it ourselves in the editing program, but now in the 2.0 versions, we have brought the ability to upload our input video in order to get a full dubbed video by making the process easier. This is how I upload my input video. And finally, let's create a final folder in this region where the result will come out. And let's select it. After selecting our folder, all the selections are now ready, and the libraries here generally use female voices. The reason for this is that female voices are usually used because the frequency in this free library is high. Now we will get a result as if a woman speaking German has dubbed Mark Zuckerberg. Now we start our process by saying convert. That's how the process was finalized, and the results are here both as audio result and video result. Now let's see the result of our video here.
Die Zukunft hängt von uns allen ab. Und ob man Facebook nun mag oder nicht. Ich denke, wir müssen erkennen, was auf dem Spiel steht. Und zusammenkommen, um in diesem kritischen Moment für die Meinungsäußerung und die freie Meinungsäußerung einzutreten. Es ist wirklich toll, heute hier in Georgetown bei Ihnen allen zu sein. Bevor wir beginnen, möchte ich einen Moment innehalten, um zu würdigen, dass wir heute eine Ikone verloren haben. Elijah Cummings. Er war eine starke Stimme für Gleichberechtigung und sozialen Fortschritt und dafür, die Menschen zusammenzubringen.
This way we get the results. Now here we have a folder like this, timing info and unspeeded blocks of some blocks. What is the logic or meaning of this? The meaning of this is this. In order to fit into certain intervals in our subtitle, that is, to fit into the time intervals here, these vocalization results may need to be accelerated to fit into this interval. So don't talk if it's not enough. In certain ratios, see here for example, the first block was featured in the main video at 1.32x and 32x and 1.32x. Likewise, the second block was sped up with 1.35x. The third block was sped up by 1.16x, and the fourth block was sped up by 1.20, which is actually close to 1. Here it also offers us this as an alternative option. If you don't want it to be sped up, you can take the unspeeded blocks here, and here are our unspeeded results. So the first block in the text may have been spoken fast in the main video. But if you need the unspeeded version here, and if the method we suggest can be applied, in other words, when you slow down the video a little bit and use the original audio at this 1.0 speed, we will still keep a synchronization in the video. In this respect, we also create such a timing info folder. This is how we present you the unaccelerated versions of the accelerated sections in the main video and audio. In this way, we offer you this as a kind of additional option so that you can use it as you wish. I would like to say one more thing here. Let's say that maybe there was a clapping sound in the background of this video. To get these, let's show it from here, for example. There is a music sound in the background. There is a clapping sound here.
The future depends on all of us. And whether you like Facebook or not, I think we need a critical moment. It's really great.
We have another application to capture these types of background sounds. This is our multi-audio speaker detection program called Mate. It is located in our audio separation section. If you wish, I would like to show a brief example of this. As input media, I select our same folder, our same video. Then it tells me to select an output folder. Let's create a Mate01 folder here. Here, our model is trying to separate up to 4 channels of audio on different channels. Let's try to detect this. If we wish, we can try to add this sound in an editing program later. In this way, we also have the chance to get the parts of the original video that we call the background environment sound. In ElevenLabs STSS, we have the chance to add this environment sound, but we haven't added free gTTS yet. Maybe we can add it here for you to try in the future. For now, as we have said many times, our program will be in ElevenLabs Google Cloud and Microsoft Azure programs. Now the detection is complete. When we look, for example, we see 2 results here, normalized and original. Normalized is when the sounds we call normalized are normalized to a level as high as possible, in other words, to hear the sounds more clearly. Original is the actual sounds that do not drown out the main speech. For the first detection, let's try to find the voices starting from normalized and the correct background sound from 4 channels. There is no sound in the vocals section. Let's look at the drums section. There is a distorted sound here, so we don't have a suitable sound channel here. For bass, the result is usually correct. As you can see, we were able to get our background sound here. Here too, it is usually the voice of the main speaker.
And whether
by selecting the original bass, we indicate that this is Pika's environment. By adding the bass original and this as a background sound in an editing program, we get a sound even closer to the original video. In this way, we have introduced our free gTTS S2SS audio application to you. We will try to introduce you one by one with our other applications and many different applications in the longer term. Goodbye for now.